Okay, time for the second video. I'm really sorry if that first video was kind of hard to follow along with. Like I said, this is my first time teaching it, and not having you guys in front of me to kind of feed off of is really, really challenging for me. So I'm really sorry about that first video. If it didn't make sense, do not worry. I think that this second video is definitely going to help you understand what I was trying to get at and where we are headed with this process. So like I said, we started this unit with solving systems of equations, and then we moved on to matrices and all these different things involving matrices. So I want to continue with that and kind of link the two together. So how do we incorporate matrices with solving systems of equations? Well, I'm going to show you today. So if I have this equation where I have 2x, I am going to change colors a lot here, so just bear with me. Minus 3y, and that, I should probably use a different color. Let's use green, equals negative 13. And then I have, nope, got to move on to my other colors. 4x, and then plus y, and that's going to equal negative 5. So this is a very colorful set of equations. So this is your most basic systems of equations. So we could do multiple things here. We could solve for y in that second equation and substitute. We could solve this by elimination. We could solve both equations for y and then graph them and figure out where they intersect. All of those things are things that we can do. But I said in this video that I wanted to link matrices with systems of equations. So what we can do is take this system of equations and we can make a set of different matrices out of it. So if I wanted to do that, I'm going to take the coefficients of all of my variables as well as my constants, and I'm going to plug them into different matrices. So my first matrix is just going to be made up of my coefficients. So I'm going to kind of make it off over here to the side. So that means I'm going to take my coefficients of 2, of 4, of negative 3, and of, we'll use yellow, positive 1. And that makes up my first matrix. So that's just my coefficient matrix. And what I can do is say that I'm going to multiply this by my variable matrix, which is that x and y. So if you think about matrix multiplication, what I'm really doing is this times this, and that makes up my first matrix you see there. 2 times x gives me this. Negative 3 times y gives me this, and when I add them together, I get this nice equation here. So let me undo all those circles. And I could do the same with the bottom. I can do 4 times x and get this guy, and 1 times y to get my y here. So we can create these matrices from our system of equations by simply taking our coefficient matrix, which is the first, and multiplying it by a matrix made up of my variables. So you always want to go in order from left to right. We're always working from left to right. So that's why my 2 came first and then my negative 3. And that's also why my x came first over my y, because x was first in the equation and y was second. So what I can do is set this equal to a matrix made up of my constants. So this equals a matrix made up of my constants. So negative 13, maybe, and negative 5. So now I need to figure out what my matrix, I'm trying to figure out my values for x and y, right? That's the whole point of solving a systems of equations. We want to figure out where these two functions are crossing each other. That's what we're looking for. And that's at the value, whatever x, y is. So we need to solve this. So we need to figure out how we're going to solve this. Now remember, it goes back to that A times A inverse equals that identity matrix. So A times its inverse gives me that property of 1 kind of a thing. So I'm going to go ahead and call my coefficient matrix A. I'm going to call this guy A. We're just going to call this X. And then we're going to call this one B. That's my matrix B. So in order to figure out what my X is, so I'm trying to solve for X here, right? So I need to do something to get rid of that A. Well, to get rid of it, to make it 1, I need to do this property, which is multiplying by the inverse. So I'm going to end up needing to do my A inverse times my A, which is being multiplied by X, and that's going to equal whatever I do to one side, I have to do to the other. So A inverse times my B matrix. So I get something of this fashion when I go to eliminate that A matrix on the left side. Okay, so when we do this, these guys basically just cancel each other out. So I'm left then on this left side with X, and that's going to equal whatever my inverse to my A matrix was times that B matrix. So what we need to do now is we need to figure out what is the inverse of this matrix. I need to figure out what my inverse is there. So what we're going to do is I'm going to go into my calculator app again. We're going to plug in our matrix. So that is alpha matrix. I have a 2 by 2 matrix this time. And then I'm just going to fill in my numbers. So my matrix was 2, -3, 4, and 1. And then to find the inverse, again, you do the caret key up to the negative first power. And then we're just going to click enter. So I get a bunch of decimals. So we're just going to leave that there for right now. And I want to go back to our problem. So what I said was I needed to multiply by the inverse matrix on both sides. That's what I did in this step right here and here. I multiplied by the inverse matrix on both sides of my equation. So what I want to do here is I want to take my inverse and I'm going to multiply it by my B in my calculator just to make it a little bit easier for me. So going back into my calculator, I'm just going to take this matrix, and if you tap it, it'll move it over so that it'll copy it. So that's my inverse. This is my A to the negative first, and I'm going to multiply it by my B matrix. So again, we're going to click alpha matrix. My B matrix is a 2 by 1, so I need to fix that and then press OK. And the matrix is made up of -13 and of -5. Let me go back here. -5. So this step that I just did in my calculator is just this part. So it's that inverse times my B matrix. And this is going to tell me what my variables are going to equal. So when I click enter, I get something that looks like -2, 3. So let's go back into here. So I got that X equaled, so my X matrix equaled -2, 3. Okay, so let's think back to what that X actually represented. Well, that X actually represented the matrix that was X, Y. Oh, my X didn't come through. Let me fix that. So that's what my X represented in that equation, and that equaled this -2, 3. So what does that tell me? What does that tell me? Well, that tells me that my X is -2 and my Y is 3. So this tells me my answer to my equation, my system of equations. So it seems like a lot of work, but since you can do it all in the calculator, it moves pretty fast. So if you would like for me to write it out with the matrices, I can do that as well. It's just a little bit more tricky just because the matrix inverse of this one was that one that had a lot of decimals in it. So just keep that in mind. So let's try another one just so that we can kind of get the gist of it. And I will again stick with a 2x2 matrix for this one, and then I'm going to bump it up to a 3x3 so that you can kind of see that as well. So let's get these numbers. So this one that I'm going to do this time is 3x minus 2y, and that's going to equal 5. And then negative 1x, and then plus 5. So we'll do plus 5y equals 7. So there's my system of equations. 3x minus 2y equals 5, and negative 1x plus 5y equals 7. So my next step is to just set up this matrix equation looking guy. So again, coefficients in my first matrix. And I'm going to multiply it by a matrix including my variables. And set that equal to my matrix of my constants. So this is what we got so far. And please feel free to pause the video at any point just so that you can kind of get caught up with where I am. I won't know, so I don't care. It sounds great to me. So what we're going to do now is, again, I'm going to kind of name things. So I'm going to call this guy my A. We will call you X. Whoops. And this is going to equal B. So I'm going to carry out that same process. To get rid of my A, I need to do, let's do light purple. To get rid of A, I need to multiply it by the inverse, which will give me that identity property. So that's going to be like that idea that when I multiply something by its inverse, I get 1. Whatever I do to one side, I have to do to the other. Ms. Gronefeld almost forgot to do that. So I multiply by the inverse on both sides. On this left side, it cancels, and I'm just left with my X. And on the right side, I need to plug this into my calculator and figure out what it equals. So far, so good. So we're just going to take some things and plug it into our calculator. So go back to the calculator app here. My first matrix, alpha matrix, it's a 2x2, sorry. I'm going to plug in my numbers, which is 3, negative 2, negative 1, and 5. I need to find my inverse here. So we take it to the negative first power. And there's my lovely inverse, which is all befungled. And just like on this, we're going to multiply it by my B. So I'm going to multiply it by this 5, 7 matrix. So we're going to take this guy and multiply it by a 2x1 matrix. That is 5 and 7. And then we click enter. So here, if you look over there on the right side of my screen, we get 3, 2. So let me go back in here. So when I did this step here, I ended up getting the matrix 3, 2. So let's go back and just remember what that X represents. Well, that's the matrix that has X and Y in it. So I just figured out what my X and Y variables were. X equals 3, Y equals 2. So there's my first two examples. Those were just simple systems of equations, just two variables, real simple. So what happens when we bump it up to 3 variables? So I'm only going to do one example like this tonight. Sorry, I said tonight. I am recording this at almost 10 o'clock at night. So yay. So let's bump it up to 3 variables, and then I'm going to have you guys practice with a couple of these for your assignment today. And you can always just like pause the video and like look at these. I will post these notes also on the Canvas page just so that you have extra access to them. So the one that I want to do, I'm going to need lots of pretty colors. Are you good if I just stick with like one color for each row? Because I think that's what I'm going to do. So our problem is X plus 2Y minus Z equals 3. 3X plus 7Y minus 3Z equals 12. And negative 2X minus 4Y plus 3Z equals negative 5. So this is a system of equations. It has 3 variables. So I need to go ahead and break down what my matrix is going to look like. So let's make our pretty coefficient matrix. So we're going to have for our first row coefficients, it's 1, 2, and negative 1. For the pink equation, my coefficients were 3, 7, and negative 3. And for my orange equation, my coefficients were negative 2, negative 4, and positive 3. So now I'm just going to multiply that by my matrix involving my variables. So I'm going to do X in blue, Y in pink, and Z in orange. And that's going to equal my constant matrix. So that's my 3, my 12, and my, negative 5. Oh, wrong color. Okay, so I've created my matrices out of my equations. So now, what's the next step? But to name everything. So we call our matrix here A. And if you don't feel like you need to do this step, that's fine. I don't really need to do this step just because I know how to do it. But if you need to do it for the first couple problems, please do so. Don't mess yourself up by trying to be cool and like jump ahead. Unless, you are cooler than me and you can jump ahead. So I have my AX equals B. That's what I'm saying represents this lovely matrix equation. So to get rid of A on both sides, we're going to multiply it by A inverse. So we have A inverse times A times X equals A inverse times my B. Beautiful. So on this left side, these guys are going to cancel. We're going to be left with X equals whatever my inverse A times B is. So let's figure out what that is. So once again, we're going back to the calculator app. I'm going to plug in my 3 by 3 matrix, which is made up of 1, 2, negative 1, 3, 7, negative 3, negative 2, negative 4, and positive 3. So So I plugged in my matrix A. I'm going to find the inverse of it. Ooh, this one wasn't bad. This is a nice, pretty inverse matrix. That's nice. So then I take this guy and I multiply it by that B matrix, which is the matrix made up of all my equals. So it equals like 3, 12, and -5. So alpha, it's a 3x1 matrix made up of 3, 12, and -5. Oops, not +5, -5. And then we click enter. So we get this nice pretty thing that looks like -2, 3, and 1. -2, 3, and 1. So let me write this down. -2, 3, and 1. So what is that really telling me? Well, that's telling me that x equals -2. Y is pink. Y equals 3. And z equals 1. And that's all there is to it. So I'm going to go ahead now and post the problems that I would like for you to do on the Canvas page under the assignment. I think I'm going to do like 5 problems today. So that's 5 problems worth 5 points. I am extending it. It will be open from 6 a.m. until midnight tonight. If you have questions, please reach out to me and I will be able to assist you in any way possible. Have a great rest of your day.